So we've finished looking at simple interest. The next one is compound interest, and this is our most common amount or common type of interest. So it's interest that is added onto the principal and reinvested to earn more. So it means that at the end of each cycle, which is usually a year, whatever is in the account is the new principal amount. So our formula is a little bit different. A, which is our final amount, P stays the same as our principal or initial amount, N is the number of compounding periods, and R is the interest rate, again as a decimal. So our interest rate, the compound interest earned can be found by the formula I equals AP. So the interest that you've earned is the amount that you invested minus that, the amount that you earned, that final amount, minus that principal amount. So our first question here is saying if $10,000 is invested at 6% per annum, calculate the final amount and compound interest earned over the 4 years. So if we work out similar to how we've been working before, what are our different bits of information? I want to find that final amount. My interest is 10,000. My rate, which is 6%, but as a decimal is 0.06. And my time is for 4 years. So remember, to get this, we divide by 100. So if we take our formula, we're going to fill in the information. The principal is 10,000, then multiplied by 1 plus the interest rate, and the N is for the number of years. So the amount that we would earn if we put all that into our calculator is $12,624.77. But the interest that I've earned is that amount minus what I started with, which is what I put into that account. So I've earned $2,624.77. So this second example, it's the same numbers, except the only difference here is that we're compounding monthly. So instead of it being per year, it's monthly. So we're still going to use these same bits of information, but I do need to do some extra calculations first. So if I have 0.6% per annum, so per year, compounded monthly, I have to divide that by 12. So it gives me 0.005. And my number of, the time that it's invested for, 4 years. But again, I need to know per month. So I'm going to times that by 12. So that will be 48 months. So I still use my exact same formula. And I still put in my $10,000. And then it's 1 plus my interest rate, which is 0.005. And it's for 48 months. So that means every month it is compounded. So if I work that out, that tells me $12,704.89. So the interest earned is $12,704.89 minus my initial amount, which was $10,000. So $2,704.89. So you can see here, it's the exact same time, same interest. However, if it's compounded monthly, you are earning that little bit extra on your investment. So definitely look into that if that is something you are going to do in relation to investing money. How often it is compounded, how often you get that interest, and what that interest rate is going to be, and do those calculations. So another example here, what principal must be invested for 3 years at 8.7% per annum so that it grows to $15,000? So if we start with filling in our letters, what principal must be invested for 3 years, so that's our term, at 8.7%, so 8.7 divided by 100, 0.087. And we want it to grow to 15,000, so that's our amount. So I'm trying to find that principal. So setting up our formula, always set it up. Principal the amount is 15,000. I want to find my principal. So 1 plus 0.087 for 3 years. Now we know from algebra in younger years that a term out the front of a set of brackets means that is a multiplication. So in order to find P, I'm going to divide by what is here on the other side of that P, on that multiplication. So we divide by 1 plus 0.087 to the power of 3. And that would tell us our principal amount that I invested was $11,678.92. Now the next part is using a table in order to do some calculations. So using this table, we need to calculate the following. So you can see here it's the period, so usually per year, the interest percentage, and then how much that would be written as a decimal if need be. So we're going to do this in different colours so we can differentiate between them all. So it says the final amount when $1,500 is invested at 5% for 7 years. So if we're looking at 5%, we're looking in this column, and we go to 7 years. Okay, so we're looking at that one for this question. So that would be 1,500 multiplied by 1.4071. That will tell us I've earned $2,110.65. So the interest is 211,065 minus my 1,500, which is $610.65. So instead of having to do the multiplications and calculate it all, that is what that bracket represents if you were to work it out on its own. So our second one, so the final amount when $20,000 is invested for 2 years at 10% compounded half yearly. So 2 years half yearly means that there are 2 years half yearly means there are 4 lots of compounds, and it's at 10%. Okay, so this is what we're looking at, our 10%. And half yearly, so that is going to be, if we divide that by 2, that is going to give us our 5%. And we have 4 lots of compounds, so 4 at 5%, this is our percentage that we're working with. So it's going to be 20,000 times 1.2155 to give us 24,310. So our interest is subtracting those amounts, which is $4,310. So our 2 years became every 6 months, so we got our 4, and our percent per annum had to be divided by 2 to get to our 5% because it was compounded every 6 months. And our last question here says, the compound interest when $3,500 is invested at 8% quarterly for 9 months. So here we need to work out our 8% and quarterly. So it's going to be, our rate is 8 divided by 4, which is 2%, or 0.02. And for monthly, 9 divided by 3, which is 3. So 9 months quarterly, so breaking it up as well. So we're going for 2% for 3 terms. So that is this amount here. So if we set it up, we have 3,500 times 1.0612, which gives us 3,714.20. So our interest is again subtracting those amounts. Gives us $214.20.